In lesson 8.4, before we begin multiplying and dividing rational expressions, we're going to look at simplifying. And we can simplify when we can factor. So for instance, if I had something as easy as 7a over 24a, hopefully you remember that we can cancel out the a's, because essentially you were saying 7 times a or 24 times a. We cannot do 7 plus a over 24 plus a. We are not allowed to do any canceling here. One other example, if I had 7 plus a over a, again, we cannot factor this. It shows addition, so we cannot cancel anything out or reduce. The only one we could do that with is this one. So if I can convert this fraction to contain multiplication or factor it, then I can reduce. So for instance, if I said x minus 4 times x minus 4, we ask ourselves what multiplies to a positive 16 yet adds to a negative 8. And then for the denominator, we can say x plus 6 times x minus 4. What multiplies to negative 24, positive 6 and negative 4, yet adds to 2. All right, so now we can go ahead and cancel. We can cross off or x minus 4's. So our answer is x minus 4 is left in the numerator and x plus 6. This is as simplified as we can get because we've changed it to addition and subtraction. Okay, so one more example. So essentially, this is a simpler problem showing the same process. I factored 30b squared, and then I factored the 45b, and then we can go ahead and cancel out our 3's because it's all multiplication now, cancel out our 5's, and cancel out some of our b's. So we are left with 2b in the numerator and a 3 in the denominator. All right, I have two examples to show for multiplying rational expressions. So the first example, we could just start by cross-canceling, saying 5 goes into 5 once, 5 into 15 is 3, and do the same thing with our x's and our y's. I tend to like to condense it and then simplify. All right, so again, you can just cross-cancel if that's what you're comfortable with. I rewrote mine a little bit. So again, 5 goes into 5 once. 5 into 15 is 3. 3 into 3 once. 3 into 27 is 9. And I can do some more canceling there. I can say 3 into 3 is 1. 3 into 9 is 3. And now I'm going to go ahead and look at my variables. Remember, when we have division, we actually subtract our exponents. So this, we say 7 minus 5. So we actually have 2 x's left over in the numerator. And here we have 3 minus 5. So we end up with a negative 2, which means we have 2 left in the denominator. You could write it as y times y times y to see that there's 3 y's in the numerator. And we have 5 y's in the denominator. So everything cancels out except for, like I said, those y squared left in the denominator. So we end up with 3x squared y squared in the denominator. Oh, this 3 here is confusing. It looks like it's in this problem. Okay, now we'll look at one that's a little bit more complicated. So the first thing that you should notice in this problem is that we have addition and subtraction signs, and we're not allowed to start simplifying until we can change it all to multiplication, and we can do that by factoring. So the key here is that we're going to have to factor in order to change it to multiplication. So we're going to start over here on the left, and we can see that we can take out a 5x. So I'm going to factor out a 5x. So I'm left with 4, because 5x times 4 would get me back to the 20x. And then we end up with a minus x. Then over here on the right, what multiplies to negative 4 and adds to 3. So we end up with x plus 4 and x minus 1. Now I'm going to go down to the denominator, x squared minus x. The only thing I can do here is to factor out an x. So we end up with x minus 1, and we can check that. X times x gets me back up to x squared. X times negative 1 gets me back up to the negative x. And now we have the difference between squares. So we know that one is going to have to be positive and one is going to have to be negative. X minus 4 and x plus 4. All right, we're going to start to cancel out. We have x plus 4, x plus 4. We can cancel x minus 1, x minus 1. We can cancel out this x and this x. So it looks like we're left with 5, 4 minus x over x minus 4. And then we look at the numerator, 4 minus x and x minus 4, and you think, they look really similar. Is there any way we could manipulate this without changing the value so that we can reduce it? And we can do that by factoring out a negative from the numerator. So let's go ahead and do that. So I have my 5. I'm going to take out a negative. I'll call it negative 1 so it's we can see it a little bit better. So then we're going to be left with x minus 4 in the numerator and x minus 4 in the denominator. So let's check that. If I said negative 1 times x, I would get back to this negative x. If I said negative 1 times negative 4, that gets me back to originally how it was a positive 4. So I know that I did that correctly. So now I can cancel x minus 4, x minus 4. My final answer, I'm only left with a negative 5. I wanted to quick throw in a problem or an example that has cubes in it. So I have the example on the top written in black, and then I was unable to factor. This looks like maybe we could factor it, but there's I can't find anything that multiplies to positive 4 and adds to negative 2, so I'm going to keep it the same. And if you remember with our cubes, we take the cube root, so we end up with x plus 2, and then we square the first term, we square the last term, and then we multiply these two together. But if you remember, we always have to have one negative in our trinomial, so it's going to be right here, which is fortuitous because now we can cancel out those. So my answer here is x minus 4 over x plus 2. Now we'll head on to division. All right, the key for dividing rational expressions is that we need to multiply by the reciprocal. So that's exactly what I did. I changed the division to multiplication, and then the second expression, we wrote the reciprocal, and then I just factored. So then we can just start our canceling. So we're left with x minus 10 over 5. This last one, again, we're going to multiply, and it would be over 1, but we're going to multiply by the reciprocal. So our expression goes to the denominator. But the main thing I wanted to remind you about is how to factor this numerator. So we multiplied the first and the last together, so we get negative 30. And then we bring down our 3x squared, we bring down our minus 10, and we ask ourselves what multiplies to negative 30 and adds to 13. So that's going to be 15x and a minus 2x. Then we're going to factor by grouping. And we have to squeeze in our plus sign. I didn't leave much room. And we can factor out a 3x. So we end up with x plus 5. Factor out a negative 2, x plus 5. So our leftovers become one parenthesis. And our lookalikes become our second parenthesis or factor. And now we can actually approach this problem. Okay, so all I had left to do was to bring down my 6x squared, and then I factored the 3x squared minus 2x. I factored out an x, so we can cancel out our 3x minus 2. So our numerator ends up to be x plus 5, and we have 6x squared, and we still have this x, so our denominator is 6x cubed. And that's as simplified as that problem can get.